Welcome to EDU World Space.
Okay, so the result from problem 46 gives us that the electric field E is equal to lambda by 2 pi epsilon naught and L upon x L squared plus 4x squared power 1 by 2. Okay, so for this question, we consider one wire. Okay, let us consider this wire of length L. Now at this point, the electric field due to this wire is along this way, right? Now this electric field has two components, E cos theta and E sin theta. Likewise, all the wires will have the horizontal components, and the opposite sides uh, will have the components in opposite direction. That is, E cos theta is the horizontal component for this wire, whereas E cos theta will be in the opposite direction due to this wire. So they cancel out each other, so only the vertical components remain, right? And since all the wires have the same length and same charge per unit length, so E sin theta is same for all the wires. So the total electric field that we can write is actually 4 times, because there are 4 wires and only the sin theta component contributes, right? So the total electric field can be written as 4E sin theta. Now the case comes out, what is sin theta? So from this right angle triangle, sin theta seems to be P by H. So perpendicular is G, whereas the hypotenuse is root under Z squared plus half of L squared. So L squared by 4, isn't it? Yes, it is. So this is the value of sin theta. So why don't we plug this in here? So the expression for ET would now be 4E as it is, and for sin theta that comes out to be twice Z upon root under Z squared plus, that is 4Z squared plus L squared, isn't it? Because I uh, simplified this fractional addition and wrote 4Z squared plus L squared, and the denominator 4 goes to the numerator and becomes 2 because it is under the root under sign. So this is the total electric field, right? Now let us substitute the value of E by keeping 8G as it is. So let me keep the remaining things as it is. 8G by root under 4G squared plus L squared as it is, and we have now E. So for E, I write lambda as it is upon 2 pi epsilon naught also as it is, right? Now the length of wire is L, and what is X? So X is the distance between the wire and the point, so that seems to be again root under L squared by 4 plus G squared, right? So this is X. Now let me remove this excess root sign. Okay, now bracket. Now the length is again L squared plus 4 times again X squared, so that is L squared by 4 plus G, right? So in the figure, this dotted line here is L squared by 4 plus G, right? Okay, so let me close this bracket and give 1 by 2 as the power. All right. Yeah. So now what we can do is simplify this expression here. So let me write this as it is. 8G lambda L can be written at the same time here. Now there are 4Z squared by L squared. Two of these are here. So 4 cancels out with 2. So there will be pi epsilon naught and 4z squared plus L squared. Okay, from the two under root signs, and from this bracket here there will be L squared. 4 cancels out, so twice L squared plus 4z squared, I missed a square here, plus 4z squared whole times half. Well, I think we have come to an end. Wow, we found out the total electric field. All right, so uh, this is the magnitude of the electric field, and the direction is will be obviously vertically upwards, because the horizontal components cancel each other and only the vertical component has been contributing in the electric field. So this ends the solution to this question. Thank you for watching.